Hello all, welcome to i-tutor Academy. In today's session, we will start with the Unit 13, subsection 5 of Mmpc 008, that is data warehouse schema. And one of the key question to answer by the database designer is how can we design a database that allows unknown queries to be performant? This question can encapsulates the difference between designing for a data warehouse and designing for an operational database and information system. In a data warehouse, one designed to support the business process rather than specific queries requirements. In order to achieve this, the designer must understand the way in which the information within the data warehouse will be used. And in general, the queries directed at a data warehouse tended to ask questions about some essential fact analyzed in different ways. For example, reporting on the average number of light bulbs sold per store over the past month and the top 10 most viewed TV program from a TV channel or channels during the past week. Top spending customers over the past quarter. Customers with the average credit card balance more than Rs 50,000 during the past year. Each of these queries has one thing in common. They are all based on factual data. The content and presentation of the result may differ between examples, but the factual and transactional nature of the underlying data is the same. Fact table and attributes. Requirement, fact, attribute. Requirement is sales of light bulb TV channel programs, customer spend, customer account balance, account transactions. And in fact, the transaction in a period, channel pay-per-view transaction and loyalty card transaction. So there is attributes also. So please refer this table. Fact data process some characteristics that allow the underlying information in the database to be structured. Facts are transactions that have occurred at some point in the past and are unlikely to change in the future. Facts can be analyzed in different ways by cross-referencing the fact with the different reference information. For example, we can look at sales by store, sales by region, or sales by product. In data warehouse, facts also tended to have few attributes because there are no operational data overhead. And one of the major technical challenge within the design of a data warehouse is to structure a solution that will be effective for a reasonable period of time. And this implies that the data should not have to be restructured when the business changes or query profile change. So here is one figure 13.5, that is star schema. So there is fact, dimensions, customer event is divided into three. There is customer, time and location. The inherent advantage of factual transactions is that their content is unlikely to change regardless of how it is analyzed. Also, the majority of the data volume of a data warehouse comes from the factual information. And it is therefore possible to treat fact data as a read-only data and the reference data as data that is liable to change over time. Thus, if reference data need to change, the voluminous fact data would not have to be changed or restructured. Star schemas, so called due to their star-like appearance, are physical database structures that store in the factual data in the center, surrounded by the reference data. The dimension table should be relatively small in comparison to the size of the data warehouse so that restructuring costs are small as long as the keys to the fact table are not changed. In star schema arrangements, the reference information is often denormalized to a single table to speed up query performance, and the redundancy overhead are acceptable as the size involved are small and even the reference information changes infrequently. The dimensional information represented by the reference data is often organized in form of concept hierarchies that are used for analysis and designing data warehouse aggregation. A typical concept of hierarchy for a retail chain is depicted. So here is figure 13.6, that is concept hierarchies. So there is price and it is go to product, there is name, color, style, size, etc. Price, then store, region is there, section, department, business units are there. The number of concept hierarchies that can be defined on any a given dimension is by no means restricted to one. There may be several arbitrary concept hierarchies in use in any organization to enable data analysis from various angles. Figure 13.7 is here multiple hierarchies. And how multiple hierarchies: day or date, there is week, 6 weeks, and day, there is month, year, Easter, and summer. And when the concept hierarchies and grouping are incorporated into a star schema diagram, the appearance resembles a snowflakes, hence schema of this type are called snowflake scheme. There is snowflake schema, there is you know fact is there, snowflake dimension is there, star dimension is here. Sales transaction, again it divided into locations, then regions is there, week is there, month, time, summer sale time is there, Easter sale is there, like that. And media data, the metadata in a data warehouse is similar to the data dictionary in the context of the database. It stores data about data in the data warehouse. Type of metadata. Metadata in a data warehouse fall into three major categories. There is operational metadata, extraction and transformation metadata, end user metadata. Operational metadata, as already discussed, data for the data warehouse comes from several operational systems of the enterprise. These source systems contain different data structures. The data elements selected for the data warehouse have various field length and data types. Selecting data from different sources files and loading it into the data warehouse requires splitting of records, combining part of records from different source files, and dealing with multiple coding schemes and file length. Next is extraction and transformation metadata. Extraction and transformation metadata contain data about the extraction of data from the source system, namely the extraction frequencies, extraction methods, and business rules for the data extraction. And end user metadata. The end user metadata is the navigational map of the data warehouse. It enables the end user to find information from the data and warehouse. The end user metadata allows the end user to use their own business terminology and look for information in those ways in which they normally think of the business. And special significance: why is metadata especially important in a data warehouse? First, it acts as the glue that connects all part of the data warehouse. Next, it provides information about the content and structures to the developers. Finally, it opens the door to the end users and makes the content recognizable in their own terms. Metadata requirement. According to Imon, a new user approaching a data warehouse wants to know and what table, attributes, and key does the data warehouse contain. From where did each set of data come? And what transformation logic was applied in loading the data? How has the data changed over time? What aliases exist and how they related to each other? And next is table 13.4 is use of metadata. Analysis and discovery. IT professionals, power users, casual users is there. Meaning of data, information access is like. Metadata components are warehouse metadata is not very different in kind from ordinary database metadata, although it is versioned in order to permit historical analysis. Mapping. The mapping information records how data from operational source is transformed on its way into the warehouse. Typical content are identification of source field, symbol attribute to attribute mapping, attribute conversation, physical characteristics conversation, encoding reference table conversation, naming changes, key change, default logic to choose from among multiple source, algorithmic changes, etc. Extract history. Whenever history information is analyzed, meticulous update record have to be kept. The metadata history is a good place to start any time based report because the analyst has to know when the rule changed in order to apply the right rules to the right data. Miscellaneous aliases can make the warehouse much more user friendly by allowing a table to be queried by widget product by each factory rather than mf stats. And alias also come in useful when different departments want to use their own names to refer to the same underlying data. and often part of the same data warehouse may be in different stages of development. Status information can be used to keep track of this. For instance, table might be classified in design, in test, and inactive or active. And volumetric information lets users know how much data they are dealing with, so that they can have some idea about how much their queries and will cost in terms of time and computation resources. And volumetric could useful include such an information as number of rows, growth rate and usage characteristics, indexing and byte specification. And it is also useful to publish the criteria and time scale for purging all data. Summarization and aggregation algorithms. As discussed above, a typical data warehouse contains lightly and heavily summarized data and aggregation as well as full detailed records. The algorithmic for summarizing the detailed data are obviously of interest to anyone who takes responsibility for interpreting the meaning of the summaries. Relationship artifacts and history. Data warehouse implement relationship in a different way from product database. Metadata pertaining to related table constraints and cardinality are maintained together with the text description and worship records. Ownership or stewardship. Operational databases are often owned by particular departments or business groups. In an enterprise data warehouse, however, all data is stored in a common format and accessible to all. And access patterns, it is desirable to record pattern of access to the warehouse in order to optimize and tune performance. Less frequently used data can be migrated to cheaper storage media, and various methods can be used to accelerate access to the data that is most intimate. Reference table or encoded data. Reference data is stored in an external table and contains commonly used transactions of encoded values. The content of this table must be stored in order to guarantee the ability to recover the original and unencoded data together with the effective from and effective to database. And data model design reference. Building a data warehouse without first constructing a data model is very difficult and frustrating. When data model is used, metadata describing the mapping between the data model and the physical design should be stored. This allows all ambiguities or uncertainties to be resolved. From the point of view of the query manager of the data warehouse, the metadata repository can be perceived to have three logical layers: the information navigator, the business metadata, and the technical metadata, like that. And here is metadata repository and information navigator. Navigation routes through warehouse content, browsing of warehouse tables and attributes, query composition, report formatting, drill down and roll up, report generation and distribution, temporary storage result. Business metadata, source system, source target mapping, data and transformation, business rules, summary database, warehouse table and column in business terminology, query and reporting tools, predefined queries, formatted report and data load and refresh schedules and support contact, all AP data and access authorization. Technical metadata, source system, data model and structure of external data sources, staging area, file layout, target warehouse data model, source staging area mapping, staging area warehouse mapping, data extraction, etc. Okay, so please refer that figure 13.9 of metadata repository. Next is data warehouse and the web. The professor Peter Drucker, the senior guru of management practice, has admonished IT executives to look outside their enterprises for information. He remarks that the single biggest challenge is to organize outside data because change occurs from the outside. He predicted that the obsession with internal data would lead to being blindsided by external forces. The majority of data warehousing efforts result in an enterprise focusing inward. However, the enterprise should be keenly alert to its externalities, and as markets become turbulent, an enterprise must know more about its customers, suppliers, competitors, government agencies, and many other external factors. The importance of external data and the challenges faced in integrating external data with the internally sourced data was discussed in the section on load manager above. And in the same section, it was mentioned that some externally sourced data is often distributed through the internet. Reliability of web content. Many question of the reliability of web content as they should. However, few analyze the reliability issue to any depth. The web is a global bulletin board on which both the wise and foolish have equal space. Acquiring content from the web should not reflect positively or negatively on its quality. And consider the following situation: if you hear buy IBM stock because it will double over the next month, your reaction should depend on who made that statement and in what next context. The context should also be considered when judging the reliability of web content. Think of web resources in terms of quality and coverage as shown in the figure 13.10. Here is web based information sources. So, corporate data, government data, commercial database is there. So, double full quality free stuff is there. In the figure 13.10, towards the top are information resources of highly quality, and resource towards the right have a wide coverage. The interesting aspect of the web is that information resources occupy all quadrants. In the upper center, the commercial outline database vendors traditionally have supplied business with high quality information about numerous topics, and however, the complexities of using these services and the infrequent update cycle have limited their usefulness. More to the left, governmental database have become tremendously useful in recent years, and earlier public information was often available only by spending many hours of manual labor at libraries or government offices. Now facilities on internet are available to provide valuable and up-to-date data via the web and virtual databases. At the left, the corporate websites often contain vast amount of useful information in white papers, product demos, audios or videos, and press release, eliminating the necessity to attend trade exhibit to learn the latest and greatest in the marketplace. Next is web farming. What is web farming? The like operational system, the web farming system provide input to the data warehouse. The result is to disseminate the redefined information about specific business subject to the enterprise sourced from the web. And the primary source of content for the web farming system is the web because of its external perspectives on the business of the enterprises. As a content source, the web can be supplemented by the intranet web of the enterprise. This concept is typically in the format of internal website, word processing documents, spreadsheet, and email messages. Most information acquired by the web farming system will not be in a form suitable for a data warehouse. Also, as discussed above, the source and quality of the content need to be judged. In any case, the information must be refined before loading into the warehouse. However, even in its unrefined state, the information obtained from the web through web farming could be highly valuable to the enterprises. Refining information. When a data warehouse is first implemented within an enterprise, a detailed analysis and re-engineering of data from operational system is required. The same is true for your web farming. Before web content can be loaded into a warehouse, the information must be refined. The process of refining information consists of four steps. There is discovery is there, and acquisition, structuring, and dissemination. Discovery is the exploration of available web resources to find those items that relate to specific topic. Acquisition is the collection and maintenance of content identified by its sources. The main goal of acquisition is to maintain the historical context such as Wikipedia so that you can analyze content in the context of its past. Structuring is the analysis and transformation of content into a more useful format and into a more meaningful structure. The format can be web pages, spreadsheet, word processing documents, and database table. Dissemination is the packaging and delivery of information in to the appropriate customers either directly or through a data warehouse. A range of disseminating mechanism is required from the predetermined schedule to ad hoc queries. Next is online analytical processing OLAP. In the previous section, we have discussed the need for building an enterprise data warehouse and followed by discussion on its structure and ways and means of populating its with the data. The data warehouse serves as the memory of the enterprise, but memory is of little use without intelligence. The tool that analyzes data provide the intelligence. In this section and the one that follow, we discuss some of the tools available for assessing the data warehouse and transforming the data in it into information useful from the point of view of the business or business intelligence. The term online analytical processing was coined by E.F. Code in 1993 to refer to a type of application that allows a user to interactively analyze data. Online analytical processing is the method of analyzing data in a multiple dimension format, often across multiple time period, with an aim of uncovering the business information concealed with the data. OLAP enables business users to gain an insight into the business through interactive analysis of different views of business data that have been built up from the operational system. And OLAP can be defined as the process of converting raw data into business information through multi-dimensional analysis. This enables analysts to identify business strength and weakness, business trend and the underlying cause of this trend, and it provide an insight into the business through the interactive analysis. And although the OLAP application are found in widely divergent functional areas, they are all required the following key features: multidimensional view of data, calculation intensive capabilities, and time intelligence. So here is one figure is there, the OLAP system architecture. Okay, so please refer this Ignou study materials from your Mmpc 008. So the OLAP engine, which is comprised of the analytical processing logic and the data processing logic layer, and like that is a graphical user interface type tools can assess the data warehouse. This arrangement make the data warehouse data available of non-multi-dimensional analysis as well. So the OLAP engine is here. So try to analyze. The four major type of OLAP application are multidimensional OLAP, hybrid OLAP, and desktop OLAP, and relational OLAP. Multidimensional OLAP is based on multidimensional database architecture. This store data in a three-dimensional data cube that is already in the OLAP multidimensional format for slicing and dicing into analysis views. Relational OLAP products are designed to operate directly on a data warehouse built on relational database through a comprehensive metadata layer. Hybrid OLAP product primarily integrates specialized multidimensional data storage with relational database management technology. This allows a business to link multidimensional data to the underlying source data in a relational or subject-oriented database. The desktop style of OLAP allows users to perform limited analysis directly against data held within a relational or object-oriented database while avoiding many of the problems that affect hybrid and relational OLAP style. Next is data visualization. Business decision makers use data to identify opportunities, trends, and areas of concern in their respective business. Most data reaches the users in the form of tabular reports, which they find challenging to quickly and effectively absorb the information, spot pattern, and identify aberration and see hidden relationship. On the other hand, the trained human eye can easily spot patterns that the most advanced analytical tool would not be able to detect. Unfortunately, though, the volume of data that the users need to deal with is ever expanding. Data visualization tools have been evolving to the point that they can now transform large quantities of complex data into meaningful visual representation that incorporate the science behind human perception and cognition. As the old saying goes, a picture is often worth a thousand words, or in this case, a thousand rows of data. Data visualization applications render large quantities of data in the form of basic charts, graphical indicators, and scorecards, dashboard, advanced visualization animation, and virtual reality environments. By automating the fundamental aspect of data analysis, they help information users identify trends and patterns in data that are often not apparent in traditional tabular representation. Data visualization involves graphical image generation by software, where the content of the image is determined by reading digital data. The data is usually numeric, but some software can visualize concepts drawn from next text documents. The software arranges geometric shapes to create an interpretation of the data it read. Attributes such as proximity, size, and color express relationship between the geographic shapes, and figure 13.3 is example, so please refer that. And chart type, the most data visualization depends on a standard chart type, and where a rudimentary p chart or a advanced scatter plot. The list of chart types supported by software has lengthened considerably in recent years. Level of user interaction with the visualization. A few years ago, most visualization are static chart of viewing only at the cutting edge of data visualization. Today, dynamic chart type are themselves the user interface, where the user manipulates a visualization directly and interactively to discover new views of information online. And next is size and complexity of data structure represented by visualization. A rudimentary P or bar chart visualizes a simple series of numeric data points, and newer advanced chart type, however, visualize thousands of data points or a complex data structure such as neural nets. So visualization of retail data is here. Location, revenue. Figure 13.14 is there, depicts these trends and place in their context some of the common functionality of data visualization software. These trends also reveal a progression from forms of rudimentary data visualization to advanced ones, as seen moving from lower left to upper right corner in figure 1. So here is figure charting state of the art. Level of user interaction with the visualization. So emerging, evolving, maturing phases are there. The wide array of visualization software support many different chart types because the need of users vary greatly. For example, business users demand pie and bar chart, whereas scientific users need scatter plots and constellation graphs, and user looking at geospatial data need maps and other three-dimensional data representations. And the digital dashboard are popular with executive business intelligence users who monitor organizational performance metrics, visualizing them as a speedometer, thermometer, or traffic lights. Tools for charting and presentation graphics are devoted exclusively to visualizing data. However, data visualization capabilities are commonly embedded in a wide range of software type, including tools for reporting OLAP, text mining, and data mining, as well as application for customer relation management and business performance management. Business software for charting has evolved from static and superficial charts to interactive visualization with the data connectivity with the drill down. And these advanced capability are found in a new category of software and enterprise charting system, ECS. With an ECS, users can develop and deploy chart-centric and analytical applications that provide data visualization specifically for business intelligence on an enterprise scale. So, what is good visualization? Effective, there is ease of interpretation, accurate, sufficient for correct quantitative evaluation. Aesthetics must not offend viewers' sense, and adaptable is there, so can adjust to serve multiple needs. And human perception uh, capabilities, and the fact that all display need to be mapped to a two-dimensional flat computer screen or sheet of paper uh, and impose many limitations. For example, according to one researcher, inaccuracy of human perception increases in the following order when the respective techniques are used for visualization. Position along a common scale, position along identical and non-aligned scale, length, angle or slope, area, volume, hue, saturation, intensity. The technique commonly used to overcome the limitation of two-dimensional display and size restrictions are scaling and offset to fit in range, derived values to emphasize changes, projection and other combination to compress information, and random jingling to separate overlaps, multiple views to handle hidden relations, high dimension, effective grids, key and labels to aid understanding. Data mining. According to Berry and Linoff, data mining is the exploration and analysis by automatic or semi-automatic means of large quantities of data in order to discover meaningful pattern and rules. That definition justifiably arises the question, and how does data mining differ from OLAP? And OLAP is undoubtedly semi-automatic means of analyzing data, but the main difference lies in quantities of data that can be handled. Report on the past and data mining predict the future. So there is a table difference between OLAP and data mining. Features is there, OLAP, data mining. Why now? Why is data mining being put to use in more and more business? Here are some basic reasons. In today's world, an organization generates more information in a week than most people can read in a lifetime. It is humanly impossible to study, decipher, and interpret all that data to find useful patterns. A data warehouse pulls all the data after proper transformation and cleansing into well organized data structure. Nevertheless, the sheer volume of data makes it impossible for anyone to use analysis and query tools to discern useful patterns. And data mining techniques. Data mining covers a broad range of techniques. Each technique has been heavily researched in recent years, and several mature and efficient algorithms have evolved for each of them. The main techniques are cluster detection, decision trees, memory based reasoning, link analysis, rule injection, association rule discovery, outline layer detection and analysis, neural network, genetic algorithms, the sequential pattern discovery. Discussion on the algorithm associated with the various techniques has been kept outside the scope of this text for two main reasons. Firstly, because they are too mathematical, technical in nature, and secondly, because there are numerous well-written textbooks to serve the need of those who are specially interested in the subject. So summary of data mining techniques 13.7 is here. Data mining techniques, underlying structure, basic process, validation method. These are the table. Data mining application. Data mining technology encompasses a rich collection of proven techniques that cover a wide range of application in both the commercial and non-commercial realms. In some cases, multiple techniques are used back to back to greater advantage. For instance, a cluster detection technique to identify clusters of customers may be followed by a predictive algorithm applied to some of the identified cluster to discover the expected behavior of the customer in those clusters. A non-commercial use of data mining is strong and pervasive in the reach area. In oil exploration and research, data mining techniques discover location suitable for drilling based on potential mineral and oil deposits. Pattern discovery and matching techniques have military applications in assisting to identify target. The scientific community makes use of data mining to a moderate extent, but the technology has widespread applications in the commercial arena. Most of the tools target the commercial sector, consider the following list of a few major application of data mining in the business area. Customer segmentation. This is one of the most widespread applications. Business use data mining to understand their customers. Cluster detection algorithm discover cluster of customers sharing the same characteristics. Market basket analysis. This very useful application for the retail industry. Association rule algorithm uncover affinities between product that are bought together and other business such as upscale auction houses use these algorithms to find customers to whom they can sell higher value items. Risk management. Insurance companies and the mortgage business use data mining to uncover risk associated with the potential customers. Fraud detection. Credit card companies use data mining to discover abnormal spending patterns of customers. Such a patterns can expose fraudulent use of the cards. Delinquency tracking. Loan companies use the technology to track customers who are likely to default on repayment. Demand prediction. Retail and other business use data mining to match demand and supply trends to forecast for specific product. Table 13.8 is there. So there is application of data mining techniques. Application areas are here. Example of mining functions, mining process, mining techniques are there. The data mining project is here. Step 1, define business objective. Step 2 is prepare data. Step 3 is perform data mining, and step 4 is evaluate results. Step 5 is present discoveries, and step 6 is ensure usage of discoveries. Selecting data mining software tools. Before we get into a detailed list of criteria for selecting data mining tools, let us make few general but important observation about tool selection. The tool must be able to integrate well with the data warehouse environment by accepting data from the warehouse and the compatible with the overall metadata framework. The pattern and relationship discovered must be accurate as possible. Discovering erratic pattern is more dangerous than not discovering any pattern at all. So data assess. The data mining tool must be able to assess data sources including the data warehouse and quickly bring over the required data sets to its environment. Data selection. While selecting and extracting data for mining, the tool must be able to perform its operations according to a variety of criteria. Sensitivity to data quality. Because of its importance, data quality is worth mentioning again. The tool must be able to recognize missing or incomplete data and compensate for the problem. Data visualization. Data mining techniques process substantial data volume and produce a wide range of results. Inability to display results and graphically and diagrammatically diminishes the value of the tool severely. Extensibility. The tool architecture must be able to integrate with the data warehouse administration and other functions such as data extraction and metadata management. Performance. The tool must provide consistent performance irrespective of the amount of data to be mined, the specific algorithm applied, the number of variables specified, and the level of accuracy demanded. Scalability. Data mining needed to work with a large volume of data to discover meaningful and useful patterns and relationships. Openness. This is a desirable feature. Openness refers to being able to integrate with the environment and other type of tools. The ability of the tools to connect to external application where users could gain access to data mining algorithm from the application is desirable. Suite of algorithm. A tool that provides several different algorithms to rather than one that supports only a few data mining algorithm is more advantageous. Multi-technique support. A data mining tool supporting more than one technique is worth consideration. The organization may be presently need a composite tool with many techniques, but a multi-technique tool open up more possibilities. So activity B is here based on this subsection, and please go through it. Benefit of data mining. Without data mining, useful knowledge lying buried in a mountain of data in many organizations would never be discovered, and the benefit from using the discovered pattern and relationships would not be realized. Application of data mining and have indicated the implied benefits. Just to appreciate the enormous utility of data mining, the following list enumerates some real world situations. In a large company manufacturing consumer goods, the shipping department regularly ships order and hides the variation between the purchase order and the freight bills. Data mining detects the criminal behavior by uncovering patterns of orders and premature inventory reduction. A mail order company improves direct mail promotion to prospect through more targeted campaigns. And like that, there is many point. You just go through it one by one. In between any doubts, you can contact us. Summary of this unit is here. Information for strategic decision is making of utmost importance to organization. Due to several practical difficulties with the structure and nature of data held in operational system in generating the required information and availability of secondary data worldwide, the concept of data warehousing has emerged. In the data warehousing environment, data collected from internal operational system as well as data from external sources is loaded into subject oriented, time variant, integrated and non-volatile environment. The data warehouse environment is carefully designed with the time span, granularity, aggregation, dimensionality, and partition in mind. The initial data feed to the data warehouse as well as regular loading of data takes place in three phases: extraction, transformation, and loading, and is done by load manager component of the data warehouse. The data in the data warehouse is organized in terms of fact data and dimension data. The star and snowflakes schemas used in data warehouse support the separation of fact data and dimension data, as well as efficient query process. So this is summary of this unit. Unit and exercises is there. So this is 10 questions is there in unit and exercises. There is, what are the practical difficulties of using an operational systems database to service the information need of strategic decision making? Briefly explain the importance of the extract, transform, load operation and the function of the load manager component of a data warehousing. Explain briefly the terms subject orientation, granularity, aggregations, partitioning, the time variancy. In the context of a data warehouse, what is a concept hierarchy? What do you mean by factual information? What is a snowflake schema? Why is it important to separate fact data from reference data in a data warehouse? And why is metadata important component of a data warehouse? What is a metadata repository and how is it used by the query manager component of a data warehouse? What do you mean by business intelligence and what is an OLAP engine? And explain how the progress of data visualization technology in recent years has helped data analysts and business decision makers. How can you use the web as a data source for your data warehouse? What type of information can you get from the web? Explain briefly the steps needed to ensure that only good quality, reliable data is loaded into the data warehouse from the web. And how is data mining differ from OLAP? Explain briefly. Okay, so these are the questions from this unit. Try to do it. It will help you for your term and examination. And for more MBA videos, you just do like, share and subscribe our channel. Thank you so much.
i-tutor Academy presents Ignou MBA complete syllabus coverage classes for individual students, semester-wise subject with online and flexible timing. For more details, contact on +916 238 21785.